So this is labeled Module 4, but it's actually Module 5. Kinetic energy is equal to 1/2 mass times velocity squared, where m signifies mass and v signifies velocity. E equals q plus w. W equals F times D. E of the universe is equal to E of the system plus E of the surroundings, and delta E of universe is equal to delta E of system plus delta E of surroundings. Delta E of universe equals 0. Delta E of system plus delta E of surroundings equals 0. So these here are not subscript, and they should be. So let me put those in a subscript. So they're the same as everything else. Okay, or delta E system is equal to negative delta E surroundings. Classifying heat and energy. Oops. Sorry. U system equals Q system plus W system. QP. Enthalpy and thermodynamics. Q equals mc delta T. M equals Q divided by the quantity is C delta T. C equals Q divided by the quantity m delta T. Delta T equals Q divided by the quantity mc. Enthalpy and thermodynamics. Units, I'm going to go ahead and call that, all right, J equals joules. Okay, so units equals joules per gram degrees, excuse me. Units, joules per gram degree Celsius, or joules gram to the -1 degrees Celsius to the -1. So here, J equals joules, G equals grams, degrees Celsius, degrees Celsius. Mass, M equals D multiplied by V. Joules per gram Kelvin, or joules gram to the -1, Kelvin to the -1. Okay, so K equals Kelvin. Enthalpy and thermodynamics. Q equals question mark. M equals D multiplied by V equals 1 gram per milliliter times 250 milliliters equals 250 grams. C equals 4.184 joules per gram degree Celsius from your list of specific heat capacities. Delta T equals TF minus TI equals 100 degrees Celsius minus 20 degrees Celsius equals 80 degrees Celsius. Q equals MC delta T. Q equals 250 grams, 4.184 joules per gram degree Celsius, multiplied by 80 degrees Celsius equals 83,680 joules, or 83.7 kilojoules. Correct sig figs, or correct significant figures. Calculation of enthalpy. Delta H reaction, delta H formation at standard conditions. Delta H formation at standard conditions. So right here, this little degree mark, when it's next to that H, means standard conditions, and the little F as a subscript, it's going to be hard to do. Okay, F, not sure what I just did. Okay, so F as the subscript to H means formation. Okay, so 1/2 mole of gaseous hydrogen reacts with 3/2 moles of gaseous nitrogen to form 1 mole of gaseous ammonia. Delta H formation at standard conditions is equal to -46.2 kilojoules per mole. 3 moles of carbon graphite plus 4 moles of gaseous hydrogen goes to 1 mole of C3H8 gaseous. Delta H of formation at standard conditions equals negative 103.8 kilojoules per mole. 3/2 moles of gaseous oxygen goes to O3 gaseous. Delta H of formation under standard conditions equals 143 kilojoules per mole. Delta H of reaction at standard conditions is equal to sigma N delta H of formation at standard conditions of products minus sigma N delta H of formation of reactants. So the sigma just means some, but I would just say sigma. C3H8 gas plus 5O2 gas goes to 3CO2 gas plus 4H2O gas. Delta H of formation under standard conditions, C3H8. Not sure why these are not subscript. Okay, these little numbers need to be subscript. C3H8, negative 103.8 kilojoules per mole, O2. 0 kilojoules per mole, this is the most stable state of oxygen. CO2, negative 393.5 kilojoules per mole. H2O, let's see, there should be states here. I'm not sure where this is coming from, but there should be a state here, and that's going to make a difference. If I had something in parentheses like L or like G, that's going to be important to include. So be sure when you're reading this, you include the state, whether it's G for gas, L for liquid, or S for solid. Negative 241.8 kilojoules per mole. Step 3. Delta H reaction at standard conditions equals sigma N delta H of formation of products at standard conditions minus sigma N delta H formation standard conditions of reactants. Sigma N delta H of formation of products at standard conditions equals the quantity of 3 moles of carbon dioxide multiplied by 393.5 kilojoules per mole of carbon dioxide plus 4 moles of H2O multiplied by 241.8 kilojoules per mole of water equals negative 1,180.5 kilojoules plus negative 967.2 kilojoules equals negative 2,147.7 kilojoules. Sigma N delta H formation of standard condition of reactants equals, okay, and this F here should be, this F right here should be a subscript. 1 mole of C3H8 multiplied by 103.8 kilojoules per mole of C3H8 plus 5 moles of O2, this should be subscript. 5 moles of O2 times 0 kilojoules per mole of O2 equals negative 103.8 kilojoules plus 0 kilojoules equals negative 103.8 kilojoules. Delta H reaction at standard conditions equals sigma N delta H F of products, standard conditions, minus sigma N delta H formation of reactants at standard conditions. Delta H reaction at standard conditions equals negative 2,147.7 kilojoules minus negative 103.8 kilojoules equals negative 2,043.9 kilojoules. Applying stoichiometry to enthalpy. C3H8 gas plus 5O2 gas goes to 3CO2 gas plus 4H2O gas. Delta H reaction at standard conditions equals negative 2,043.9 kilojoules. 2 moles of C3H8 gas plus 10 moles of O2 gas goes to 6 moles of CO2 gas plus 8 moles of H2O gas. Delta H of reaction standard conditions equals negative 4,087.8 kilojoules. So one of the things I want to just make sure that after you're reading these numbers, they're called coefficients in front of the formula. After each number, here's the word mole. Okay, so 1/2 mole C3H8 gas plus 5/2 mole O2 gas goes to 3/2 moles of CO2 gas plus 2 moles of H2O gas. Delta H reaction at standard conditions equals negative 1021.95 kilojoules. 1 mole of C3H8 is the same as negative 2043.9 kilojoules. 1 kilogram C3H8 times 1,000 grams per 1 kilogram times 1 mole C3H8 per 44.11 grams of C3H8 equals 22.67 moles of C3H8. 22, hold on a second. Okay, some of the stuff wasn't quite in the stream. 22.67 moles of C3H8 times negative 2043.9 kilojoules per 1 mole C3H8 equals 46,336 kilojoules, or 4.63 times 10 to the 5th kilojoules in correct significant figure. Solving problem with Hess's law. Calculate delta H reaction for 4 moles NH3 gas plus 5 moles of O2 gas going to 4 moles of NO gas plus 6 moles of H2O gas from the following data. N2 gas plus O2 gas goes to 2 NO gas. Delta H equals negative 180.5 kilojoules. N2 gas plus 3 H2 gas goes to 2 NH3 gas. Delta H equals negative 91.8 kilojoules. 2 H2 gas plus O2 gas goes to 2 H2O gas. Delta H equals negative 483.6 kilojoules. 4 NH3 gas plus 5 O2 gas goes to 4 NO gas plus 6 H2O gas. N2 gas plus 3 H2 gas goes to 2 NH3 gas. Delta H equals negative 1.8 kilojoules. 2 NH3 gas goes to N2 gas plus 3 H2 gas. Delta H equals 91.8 kilojoules. 2 times 2 NH3 gas goes to 2 N2 gas plus 2 times 3 H2 gas. Delta H equals 2 times 91.8 kilojoules. 4 NH3 gas goes to 2 N2 gas plus 6 H2 gas. Delta H equals 183 kilojoules. N2 gas plus O2 gas goes to 2 NO gas. Delta H equals negative 180.5 kilojoules. 2 N2 gas plus 2 O2 gas goes to 2 times 2 NO gas. Delta H equals 2 times negative 180.5 kilojoules. 2 N2 gas plus 2 O2 gas goes to 4 NO gas. Delta H equals 361 kilojoules. 2 H2 gas plus O2 gas goes to 2 H2O gas. Delta H equals negative 483.6 kilojoules. 2 H2 gas plus O2 gas goes to 2 H2O gas. Delta H equals negative 483.6 kilojoules. 3 times 2 H2 gas plus 3 O2 gas goes to 3 times 2 H2O gas. Delta H equals 3 times negative 483.6 kilojoules. 6 H2 gas plus 3 O2 gas goes to 6 H2O gas. Delta H equals negative 1,450.8 kilojoules. 4 NH3 gas goes to 2 N2 gas plus 6 H2 gas. Delta H equals 183.6 kilojoules. 2 N2 gas plus 2 O2 gas goes to 4 NO gas. Delta H, there's a number missing here. It's 361 kilojoules. 6 H2 gas plus 3 O2 gas goes to 6 H2O gas. Delta H equals negative 1,450.8 kilojoules. So that's all you're doing. And here for NH3 gas goes to 2 N2 gas plus 6 H2 gas. Delta H equals 183.6 kilojoules. It's just reading it from left to right. I know this is stricken, but I don't really know how you can really say that. You just really have to read it left to right. And then finally here, 4 NH3 gas plus 5 O2 gas goes to 4 NO gas plus 6 H2O gas. Delta H equals 186.6 kilojoules plus 361 kilojoules plus negative 1,450.8 kilojoules equals negative 903.2 kilojoules. Calorimetry. Q of surroundings equals negative Q of system, and Q of water equals negative Q of reaction. Q equals MC delta T. Constant pressure calorimetry. Example. Q of water equals M of water, C of water times delta T of water. M of water equals 100 grams. C of water equals 4.184 joules per gram per degree Celsius. Delta T water equals 22.5 minus 22.0 equals 2.5 degrees Celsius. Q of water equals 100 grams times 4.184 joules per gram degree Celsius times 2.5 degrees Celsius equals 1046 joules. C of metal equals Q of metal divided by M of metal delta T of metal. Q metal equals negative 1046 joules. M of metal equals 45 grams. Delta T of metal equals 22.5 minus 70 equals negative 47.5 degrees Celsius. C of metal equals Q of metal divided by M of metal delta T metal equals negative 1046 joules divided by 45 grams times negative 47.5 degrees Celsius equals 0.489 joules per gram per degree Celsius. Bomb calorimeters. Q reaction equals negative C calorimeter delta T. Q of reaction equals negative C calorimeter delta T equals negative 5.2 kilojoules per degree Celsius times 23.72 minus 21.32 degrees Celsius equals negative 12.48 kilojoules. All right, negative 12.48 kilojoules divided by 0.750 grams equals 16.64 kilojoules per gram, or 16.6 kilojoules per gram in correct sig figs. 16.6 kilojoules per gram times 1,000 joules per 1 kilojoule times 1 cal per 4.184 joules times 1 kilocal per 1,000 cal times 1 cal with a capital C per 1 kilocal equals 3.97 cals per gram.